Alright, so now we're going to talk about operations on functions. Now some of the stuff we have already talked about, but let's just go ahead and go to example one so we can kind of go over it. Now on all of these, right, they want you to actually show them each operation on this function. So f plus g of x, what that really means, and you actually have an example of this if you print out your notes. F plus g of x actually means just adding function f plus function g. So essentially all you're doing is just adding like terms, okay? So on this part right here, f plus g of x is actually the same thing as adding function f of x plus function g of x. Then we're just going to add like terms. Now, on this all you're doing is adding, alright? So you're adding this function and this function together. So we have 8x plus 4x, which is 12x. And then we have negative 3 plus 5, which is positive 2. And that's pretty much it for that. Now if you have f minus g of x, that's the same thing as function f of x minus function g of x. So essentially all you're doing is grabbing this function, which is f of x, and then you're going to subtract function g of x, which is 4x plus 5. Now, as I've told you in the past, remember that there's really nothing hard about this. You just have to remember that this negative right here, this minus, is going to make this minus, and it's going to switch the sign. So it's essentially like you're distributing this negative to this number and this number. So now you can add the like terms, if you will. So you have 8x minus 4x, which is 4x, and then you have negative 3 minus 5, which is negative 8. Alright, so that's that for that one. Okay, so now we have f times g of x, which is the same thing as multiplying function f times function g. So all I'm doing here is I'm going to multiply 8x minus 3 times 4x plus 5. So if you look at it, all we're doing here is foiling. Alright, so we're going to go ahead and FOIL these two. So we have 8x times 4x, which is 32x squared. Then we have 8x times 5, which is 40x. So we have 40x here minus 12x. So let me go ahead and write it out. But another summary, they can probably do this middle term in your head. So we have that. And now we have negative 3 times 4x. Then we have negative 3 times 5, which is negative 15. Right, if I add like terms, I'm going to get 32x squared plus 28x minus 15. And that's your final answer down here. Alright, finally we have f divided by g of x. So that's the same thing as dividing f of x by g of x. Now on this one, they don't really want you to do this much, too much work here. All they want you to do is to write function f of x, which is 8x minus 3 in this case. And then you're going to divide that by 4x plus 5. And what they want you to do next is they want you to tell you what x cannot be equal to. And to do that is very easy. All you have to do is take the bottom of the fraction and you're going to set that equal to 0, and then you're going to solve. Alright, so all you're going to do is set the denominator equal to 0 and then solve for it. So we have 4x is equal to negative 5 if we subtract 5 from both sides. And if we divide by 4, I get this answer. So what that means is that I would need to write x cannot be equal to 5 over 4. Now for you to sort of understand what we meant by that, is that if you plug in this negative 5 over 4 into this function right here, you would be dividing by 0. You would have 8x minus 3 over 0. Alright, whatever that number is. So if you plug in this negative 5 over 4 into this x and this x, you're going to have some number over 0. You cannot divide by 0, so that's the only thing you need to do. So remember, all you need to do is set the denominator equal to 0 and solve for it. Alright, I'm going to skip, I'm going to go to number 3, so just in case you need a little bit more on that one. On number 3, all you're doing is the same thing again. So we're going to add they want you to do f plus g of x, so we're going to add those two functions. In this case, and you can go ahead and just add them, right? So you have 3x squared minus x plus 5. If I add that, I'm going to add like terms. So I have 3x squared. If I add this and this together, I get positive x. And if I add 5 and negative 3, I get positive 2. All right, so that's that for that. If I have f of x minus g of x, all right, then what happens is that we're going to have 3x squared minus x plus 5, and we're going to subtract 2x minus 3. And notice how I'm writing this in parentheses, because that minus is going to make this negative, is going to make that positive. So essentially what we have is 3x squared minus x plus 5 minus 2x plus 3. So be careful with that. Add like terms now. So we have 3x squared minus 3x plus 3. Wait a minute. Oh wait, plus 8. Yeah, we got to add like terms here, right? So we have plus 8. So that's it for that part. Now let's go to f times g. F of x times g of x. So what that means is you're going to multiply, right? So you're going to multiply these two together. Now remember, on this one you can do either the box method or just go ahead and multiply that out, just distribute twice. In this case, I think I'm going to go ahead and just distribute twice. But if you do the box method, that's fine too. It works. So we're going to multiply 2x times 3x squared, which will give us 6x cubed. We have 2x times negative x, which will give us negative 2x squared. Then we have 2x times 5, which is 10x. And now we're going to multiply, so now we're going to distribute this number across all those three. So we have negative 3 times 3x squared, which is negative 9x squared. Negative 3 times that, which is positive 3x. And negative 3 times 5, which is negative 15. Okay, so let's add like terms now. Say we have this and this, so that's going to give me negative 11. Let's see. I just noticed that I have a little mistake here. Let me see. That's okay. So we have negative 11x squared, and then we have, let's see, 13x, because we're adding that one and that one, and then finally we have minus 15, so that's not going to change. Okay, so that's it for that part. Now remember, if I ask you what is f of x, and this problem, so if you have these two, if you divide them, that all you need to do is write this function over this function, right? Now essentially all I want to know is what x cannot be equal to on the bottom. So remember, set the denominator equal to 0 and then solve. And when you solve, you get 3 over 2. So x cannot be equal to 3 over 2. Alright, so let's go ahead and go to the back now. Now on the back of this, alright, now some of this can be confusing, but it's actually not too bad. Okay, so on this one we're doing the same kind of thing. We have f of g. So essentially f of g is the same thing as f of g of x normally. That means the same thing. And g of f is the same thing as g of f of x. And that's normally how we use them. Okay. And so this is called a composition of functions. We're just multiplying them, or in this case we're putting this function g of x inside of function f and see what we get. So with numbers it can be a little bit confusing, but this is how you do it, right? So we want to know, alright, so we're going to start with function f. Now instead of, I'm actually going to write g of 6 here. And it may not be clear why I'm doing that, but remember, g of 6 has a y coordinate. So g of 6 is 0, right? So g of 6, I need to come over here, and this is the x coordinate. If I plug in 6 into function g, my output is 0. So this one is equal to f of 0. Okay? Now remember, all I'm doing is I'm going to 6. G of 6 means what is the y coordinate when x is equal to 6, essentially. When x is equal to 6, y is 0. So that's what I have here. So now, f of 0, that actually means what is the y coordinate when x is equal to 0 on function f. So come up here, and you're going to find this 0, and the output, or the y coordinate, is 9. Alright, let's do one more. So if you have f of g of 2, then what you're going to do is the same idea. You're going to go to, notice that I'm going in order. Alright, so g of 2, that will give you -1. So this would be f of -1. Now f of -1, you're going to come up here and then see what the output is. If this is the input, the output is 2. So this would be 2. Alright, let's do the next one. So now I'm going to go to the next one. So I have f of g of 9. Notice that I'm literally going in the order that I have it up here for g. Alright, so this would be, let's see, g of 9. G of 9 is 5. That's the output. And f of 5 is 6. Alright, so that's how you do the f of g of x, or what's called f composition g. Some people call it fog. You can call it whatever you want. Alright, so now we're going to go backwards. So now we're going to have g, and function f, I'm actually going to go to -1. Alright, notice that again, I'm going in order. So if x is -1, y is 2. So for this one, I would have g of 2. And g of 2 would be -1. Alright, let's do that one more time. Now we're going to go to this one. So we have g of f of 5. Now f of 5 is 6. And g of 6 is, let's see, g of 6 is 0. And finally, f of 0. Alright, so g of f of 0, when x is 0, y is 9, so this would be g of 9. And I come over here and see g of 9 is asking me what is the output, or what is the y coordinate when x is 9. The output is 5. Alright, so that's how you do it. Now every now and then, for example, in this one, if I go to this one, sometimes they don't exist. Alright, so if I write f of g of 3, for example, right now g of 3 is 7. So essentially what I have is, notice this is 7. I want to know what f of 7 is, but see, I don't have that up here, so this is undefined. So I don't really have that. I can't really do much. And then you need to do the rest of those. I'm not going to do them just for the sake of time. Alright, so then once we actually see more often are problems like this. So now on f of g, fog, if you will, f of g of x, that's what this one is. All you're going to do is plug in, there used to be an x there, right, f of x, but now you're going to plug in all of g. Now g is -5x minus 1. So again, this right here was g of x, and that's what you're plugging in. And then really after that, you're just distributing this 2 and then adding like terms. So this will be -10x minus 2 plus 7. So this is going to be -10x plus 5. Okay, so that's what f of g of x. Now, if we reverse that, if we go GOF, which is g of f of x, then what I'm doing is I'm using function g, and instead of writing an x here, I'm going to write function f of x into right here. So function f of x is 2x plus 7. So again, this is f of x. Okay, so that's going to give me negative 10x minus 35 minus 1, which is negative 10x minus 36. And that's the answer for that one, okay? All right, let's do one more. Maybe this one's a little bit more complicated. So same thing, f of g of x. Remember what you're doing is you're going to plug in g of x, which is all of this, for x here and here. Okay, so we have x squared plus 2x. Hold on, I did that backwards, my bad. Let me rewind a little bit. Let me erase that. Okay, excuse me. So you're going to plug in this function right here into here. So we have x minus 9 squared plus 2 times x minus 9. All right, so that's what we got for that part. So remember, right here we're going to FOIL, right? X minus 9 squared is the same thing as x minus 9 times x minus 9. So when you do that, assuming you know how to FOIL, you would get this. And if you distribute, you would get 2x minus 18. And if you add the like terms, you would end up with x squared minus 16x plus 63. All right. Likewise, if you have g of f of x, this actually turns out to be much easier. You're going to plug in f of x, which is this, into here. Right? So you're going to plug that in for x. So that would give us x squared plus 2x minus 9. And in this case, there's really no like terms to add, so all I want to have, excuse me, is that as your final answer.